Yeah. Good evening, everyone. Turn again. Let's start off. Come on, everyone. This was the last one that we did. Stable and unstable equilibrium. Let's start off with a question. This is an FX graph. This is point A, this is point B, this is point C. Which of the following points is stable and unstable equilibrium? Let's get this. So we have an FX graph here, and there are 3 points here. Let me draw a UX graph also. Two different questions. FX graph, ABC, which points are stable and unstable equilibrium? UX graph, ABC, which points are stable and unstable equilibrium? Yeah, rest, right? Why so many people are absent today? Hmm. Okay. Ali, long time. Gone through all the previous basic lectures. At least work par have you gone through, Ali?
No,
No. Should have gone through now. When did you come back? Hi.
2 days.
When did you come back?
2 days. Sorry, 4 days.
2 days. 4 days ago. Should have seen. No, you had time, right? You had enough time. Okay.
I'll see them after.
Let's see how to do this thing, everyone. First one. Tell me one thing. For equilibrium, what is the first condition? Force should be 0. For equilibrium, F should be 0. So here Fa C B. So force at A and force at C is 0. Force at B is not 0. So B is nothing. B is not equilibrium only in the first place. Then for stable equilibrium, we know the potential energy should be minimum. Therefore, d square u by dx square, the second differential, should be greater than 0. This you have done last time. For stable equilibrium, the energy is minimum. So the second differential should be greater than 0. But the second differential is nothing but d by dx of du by dx is minus f. F is minus du by dx. So from here we get df by dx should be less than 0. Means slope should be negative. So which point has negative slope, A or C? C, na? So therefore T is stable. This is a negative slope and this is a positive slope. The point B is nothing. The B is not only equilibrium in the first place, so there's no discussion only whether it is stable or unstable. For unstable, d square u by dx square, potential energy is maximum. So this guy should be less than 0. This will be d by dx of minus f should be less than 0. That is df by dx should be greater than 0. Basically, slope is positive. So A is unstable. Clear, everyone? So the first point was stable and unstable, right? You need to check at what points the force is 0. And then from there you proceed. Seriously, just too many people are absent today. Is there any event today? Yeah? Now this problem, right? There is another intuitive way of doing this. If you don't want to do this mathematically, listen. This method, right? What I'm teaching you now, I generally teach you medical students because they don't like this much differentiation. They're unaware. So look at this point A. If you go from point A, if you go little ahead, right? Here x is positive. If you go front, you're going ahead. What is the force here? F is positive. Means what? If you go ahead, force is also ahead. So what will happen? It will go away, right? If you go back, then force is negative. Means if you go back, force is also backward. You will go away. So what kind of point is this? Unstable, isn't it? Isn't that the meaning of unstable equilibrium? Stable means what? If you push it, it should keep coming back. Look at this thing. In a stable equilibrium, if you push it left, it will come back right. If you push it right, it will come back left. Whereas in unstable, if you push it right, it will go keep on going towards right. If you push it left, it keeps on going towards left. So if displaced right from A, force is also towards right. Meaning particle never comes back. Such kind of points are called unstable equilibriums. So this is an unstable state. If you look at point C here, if I push it forward, the force is backward. If I push it backward, the force is forward. You're getting it? So at C, if displaced forward, force is backward. Or if you displace it backward, force is forward. This is the nature of a stable equilibrium. Check. Without using any max, you can figure out like this. So at the point A and C, just displace it forward, displace it backward, and see if it is coming back or not. If it comes back, it is stable. If it doesn't come back, it is unstable. Is this making sense? This is without using any math. With maths, you can figure it out, but sometimes happens exam it doesn't click or it looks too scary. This helps. Please check out this thing, everyone. It's a good one. This came in JA exam. It's a previous year question. Everyone, please check it out. Ask me if I'm confused.
So at point B, what will it be at?
Nothing.
Okay.
It is nothing. First of all, to discuss stable and unstable, it should be what? Equilibrium.
Yeah.
Force is only not zero at point B.
Okay.
There is still a second part. What about this graph? UX graph? If it is instead of FX graph, it was a UX graph, then ABC, which are stable and which are unstable. This is easy. This is a UX graph. So at point B here, point A and point C. So first of all, for equilibrium, force should be zero. That is, slope du by dx should be zero. So here only slope is zero at B. And at B, potential energy is maximum. So B is unstable equilibrium. A and C are nothing. Clear? Yeah. Force should be zero and the potential energy is maximum. So it is an unstable equilibrium. Check it out. All got this? Next one. What happened? Displacement? Nothing. From point A, if you go forward, force is X is positive, but F is also positive. If you go behind, X is negative, F is also negative. Means what? Whichever direction you push, force is also in the same direction. So you'll never come back. If you want to come back, the displacement and force should be opposite, isn't it? So at point C, if you go forward, displacement is positive, but force is negative. Make sense? So when you want to come back, what should happen? See, if you want to come back, if I push you forward, your force should be backward. If I push you backward, force should be forward. Then you will come back, isn't it? Right, Aryan? Clear, no?
Yes, sir.
All clear with this thing? Great. Next one. Gravitational potential energy. Let's also call this thing as GPE. Let's say we take a block here like this to this point somewhere here. And let this be HA. Let this be HB. So as the block is going in some random path, the force is always mg acting downward. So work done by gravity. Since here gravity is a constant force, you can directly take F bar dot S bar minus mg j cap dot product the displacement HB minus HA j cap. So the work done turns out to be minus HB minus HA, where HB and HA are the heights of point A and point B. And we also know the change in potential energy or work done by internal conservative forces is negative of potential energy. So minus mg HB minus HA is minus delta U. Minus minus cancels off. So you end up with delta U is UB minus UA is equal to mg HB minus HA. So potential energy is nothing but mg delta H. The change in potential energy is mg into this thing. Let me write like this here. So delta U is mg delta H. So this can be also written as UB minus UA is mg HB minus HA. Now, if you choose, if you take something as a reference, if A is taken as a reference, that is HA is 0 and UA is 0, your potential energy becomes U is equal to mgh, where h is the height from the reference line. So when you keep saying the potential energy mgh, mgh, that h is actually the height from the reference line. Have a look at this. So now we are defining potential energy. You learned this in school, mgh, but we are proving it in a more technical way. Be on time, everyone. You guys are late 15-20 minutes. I and Arjun were discussing how to make a blueberry cheesecake. You guys missed the recipe. Let's see. Clear with this? So now here if I ask you a question. If I have a block here of mass m at height h, what is the potential energy of the block? What is the potential energy of the block? Anyone? What is the potential energy of the block? You can type your answers in the chat box, or you can unmute and tell. Cos theta x. First thing, right? It's not mgh. You need to ask me a question, sir. What is your reference line? If you say this is my reference 1, if this is my reference 2, if this is my reference 3, it all depends. So reference 1, reference 2, reference 3, the potential energy of the block will be, reference 1 will say how much? mgh. Reference 2 will say 0. Reference 3 will say minus mgh. You're getting it. Depending on the reference line, the potential energy can be anything. It is h is the height from reference, everyone. Theta has nothing to do with it. But same thing, when the block has come to the ground, the block comes to the ground, the potential energy becomes 0. This becomes mgh minus, this will become minus 2 mgh. Now, in all these three cases, if you observe the difference, U block minus U ground, this will be mgh, mgh, mgh. So this is an important statement here. The potential energy difference is independent of reference line. If you ask you potential energy between 2 points or 2 levels, it does not matter which one is your reference line. This is important, a simple theoretical question. This is independent of reference. Whereas potential energy depends on reference. You know, kind of think like this. Let's say I have a centimeter scale like this. If I say this is 16 centimeters, how much is this? 17. If I say this is 7 centimeters, this is how much? 8 centimeters. So whatever I take here, that will be +1, right? But what is the difference between them? Always 1 centimeter, isn't it? It doesn't matter what you take as a reference or anything, the distance is always 1 centimeter. But the reading of this thing will change depending on what I'm choosing here. If I choose 20, I get 21. If I choose 10, I get 11. If I choose 25, I get 20. But the difference is always 1. So the potential energy difference is independent of reference line, whereas potential energy depends on the reference line. Have a look at that. Do have a look at this. Clear? Next one. Any doubts on this? Everyone, Abhinav, Malika, clear with this? Aryan, Vidyut, Niranjan, all clear with this? Yasha, Ronak? Great. Next one. Spring potential energy. We'll call this thing SP. Did you guys see the next one test line, test series?
Yes.
I kept multiple chapters because I know most of you have a major test right coming up, so that also will help. So that way we have combination test. We have 3-4 chapters for combinations. We'll finish our work energy by next week, and then we'll go ahead with reoptics. We'll continue. I mean, the last week I won't take much of classes, but till then we will keep on finishing out the portion. And after Diwali, classes ka time will increase. So be ready for that.
So the multiple chapter tests will be longer,
Longer meaning?
like time wise, like like a 2 hour test or something.
No, it's like 1 hour test only.
Okay.
Okay, here, if you want, I can send more PDFs. I'll send you in the group additional papers you guys want.
No, so that's okay. No, because I have other books also at home which I need to complete.
Yeah, fine. So let's say if you're applying a force F here, now natural length, what happens? Let's say you pull this by X and you displace this by dx. And we know whenever you pull by X, the spring force will be backward. So force due to spring is minus kx bar. So work done by spring force. Now listen carefully, this is important. You will see a question where it can pop up. F dx, which is minus kx dx. So elements will go from 0 to x. This will be minus half kx square. So work done by the spring force is negative. And we know work done by a spring is minus delta u. So you end up with u is equal to half kx square. This is the energy stored in the spring, where x is elongation or compression. So whenever you stretch a spring or compress a spring, the energy stored is half kx square. And here, natural length is taken as a reference. The most important thing, right, for potential energies, always the reference line is important. If you don't define a reference line, you can't calculate potential energies. So in case of a spring, the natural length is taken as a reference. In case of gravitation, you can choose, but in case of a spring, it is already chosen. This is your spring potential energy. Have a look at this. Have a look at this. Clear? This is F external. That's your spring potential energy. And in the which? The third one? Okay. Clear. The third energy is kinetic energy. Now, this is straightforward. You got a block of mass m going with speed u. If there's a person A on the ground, and if there's a person B who is going with speed v, if you ask kinetic energy as seen from A, this will be half mu square. If you ask person B what is kinetic energy, he will say half m u minus v whole square. Kinetic energy depends on the frame of reference. Depending on which frame you're seeing, kinetic energy can be different. So So if you take kinetic energy is half mu square, we can write this thing as mu whole square by 2m or p square by 2m. Or you can write p is equal to root over 2 into mass into kinetic energy. P is momentum. That's the relation between momentum and kinetic energy. Check it out. There we have all the three energies now: spring potential energy, gravitational potential energy, and kinetic energy. Clear, everyone? Next one. Now, how will they frame questions on this thing? Say, Vartika, clear so far? Niranjan, Aditya, clear with this? We have a non-standard spring. Where F is equal to minus kx cube. X is elongation or compression from natural length. So normally spring of force is kx, na? This is kx cube. Find, let's say W1 is work done to stretch from this is work done by external force. X2 to x. W2 is work done to stretch from 2x to 3x. Find W1 by W2. So we got this non-standard spring minus half kx minus kx cube. Someone is pulling the spring, and what is the work done to pull from x2 to x and work done to pull from 2x to 3x? That ratio. Get this.
Is f external constant?
Why it should be constant? Why will it be constant? Find the work done to stretch the spring from x to 2x and 2x to 3x. Bus. It is very narrow, God. If the spring force is constant, yeah, it will also change accordingly. 1:1. So you mean to say no matter how much you pull the spring, the effort doesn't increase. Look at the force here, it's increasing as kx cube. When x is 1, it is k1 cube. When x is 2, it is k2 cube. Isn't the force increasing? Yasha, you're right. Aryan, you're wrong. Others, everyone should type your answers here. Try. Everyone got a minute. You should type your answers. Everyone should try. Don't be passive. Palak, you need to put your cam on. See, 13 by 3. Nee, Arjun, that is wrong. Manika, that is wrong. Palak, that is wrong. Niranjan, it's got some weird answers, right? Let's see. So when you go from W1, now understand here. This point here, when you're pulling, this is F external. This is spring force, okay? Both are opposite. So here F external will be equal to kx cube. So at every instant, the external force should be equal to the spring force. And the displacement is forward by dx. So work done W1 will be kx cube into dx. So why am I not writing minus sign? If I want the work done by spring force, it is minus sign. But work done by external force is plus sign. You're going from x to 2x. This guy will be 1 by 4 k x power 4. Limits will go from x to 2x. So this will be k by 4. 16 x power 4 minus x power 4. So in this case, now the potential energy of the spring will be 1 by 4 x power 4. If they ask you that question, I didn't ask you that. But here the potential energy will be 1 by 4 kx power 4. It's not half kx square. So 15 by 4 kx power 4. Same thing, work done by W2 will be kx cube dx. The limits will change from 2x to 3x. This would be k by 4. 81 x power 4 minus 16 x power 4. How much is this guy?
65.
65 by 4 k x power 4. So W1 by W2 is 15 by 60. 5 3s are 5 13s are 3 to 13. Check. Clear? Easy. So be careful. Every time the springs, they won't give you half kx square. I can change the spring of type also. So in this spring, right, the potential energy, which I didn't ask you, but the spring potential energy will be 1 by 4 k x power 4. You need to simplify your answer, na? You need to simplify your answer. Ronak, Abhinav, clear with this?
Yes.
Rehan, Arjun, Ali, got your mistake.
Yes, sir. Calculation mistake.
Aditya, got it? Can I go ahead?
Yes, sir.
Next one. Work energy theorem. Now we are slowly entering.
So can you go back for a minute? Yes, sir. Thank you.
The work done is given by integral f bar dot dr bar, and we know this is mass into acceleration. This can be written as mv dv by dr. That goes off, and you end up with mv dv u to v. This is nothing but half mv square minus half mu square. So this will give you something pretty important. So work done by all forces is change in half m v square minus half m u square, which is change in kinetic energy. The second thing we have done already this work done by internal conservative forces is negative of potential energy. These are the two things we have got till now. So work done by all forces is change in kinetic energy. Work done by internal conservative forces is negative of change in potential energy. This will be mostly like, which of the following statements are right and wrong. May you get one of these things. And people do get confused and they goof up. Yeah. No. So if you take this work done by all forces, that is equal to change in kinetic energy. Now all these forces can be classified into two types. You can split them into work done by internal conservative forces when you say internal conservative forces, example, spring forces, gravitational forces, and later on we will see electrostatic forces. That's it. At least in 11th and 12th physics, right? These are the only three things we deal with. Actually, overall, this much only we deal with. And this is also work done by external forces. When we say external forces, basically any force other than these three are external only. Example, friction, air resistance, or any other force that you apply. So all forces can be categorized into this.
Sir, what about nuclear forces?
Those things don't come, right? We don't define them. We are talking about mechanical systems now. Who will go into the nucleus and find work done?
Oh,
So we don't consider them. So there, so work done by all forces. At that point, what happens? Energy doesn't get conserved only. When you go to such a low level, molecule level, right? Law of conservation of energy fails.
okay.
It is not called law of conservation of energy. It is called law of energy plus mass conservation.
Okay.
We will see that in nuclear physics. We have chapter modern physics later on. So work done by internal conservative forces plus work done by external forces is change in kinetic energy. This is nothing but minus delta U plus work done by external is equal to delta K. So work done by external forces is change in kinetic energy plus change in potential energy. Have a look at this. I'll put it in the next page in a better format. So we got the third form here. So we got total 3 forms. Work done by all forces, change in kinetic energy. Work done by internal conservative forces, negative potential energy. Work done by external forces, change in potential plus change in kinetic. Clear? Next time. So work done by external forces is change in potential energy plus change in kinetic energy. So potential energy plus kinetic energy is called as mechanical energy. Total mechanical energy. So you can write this thing as work done by external forces is change in total mechanical energy. You can simply put it like this. So work done by external forces, final energy minus initial energy. So this, right, I like to write it in this form. E final is work done by external force, E initial plus work done by external. Because try to think of like this. It is like you have 100 rupees. I gave you 50 rupees. How much should you have? 150, no? Makes sense? It looks pretty intuitive that way. You have something, I gave you something more, and the total should be work initial plus work done by external. This will be quite useful when you're solving certain problems. So this is your third statement. Now, so this is basically work energy theorem. This is your work energy theorem, which is quite a powerful one. If the work done by external force is 0, then E initial becomes equal to E final. This is law of conservation of energy. So if you ask me which is more powerful, work energy theorem is more powerful than law of conservation of energy. Law of conservation of energy. This is a first conservation. In entire mechanics, right, you have 2 set of weapons. First weapon is force and torque equations. You learned force, torque will see in rotation. The second weapon is conservations. Conservation of energy, conservation of linear momentum, and conservation of angular momentum. So there are 3 parts in that. This is the first part in that. Literally every mechanics problem, every problem actually will fall in one of these 2 categories. Either it is a force and torques or it is a conservations. This is one. Another way to write this guy, if work done by external is 0, delta U plus delta KE is 0. So I can write minus delta U is delta KE. So you can write loss in potential energy is equal to gain in kinetic energy. It's the same thing. You're just twisting them and writing them in different forms. Loss in PE is gain in KE, or loss in KE is gain in PE. You can write either way. Have a look at this page. Please ask me if you're confused anywhere. Any step you're not clear or not convinced. Any doubts on this? Yeah, can I go ahead? Now tell me one thing. What if I take a non-inertial frame? Is work energy theorem valid in non-inertial frame? Technically, it is not, but you can make it right. So work energy theorem का modification, right? In non-inertial frames, work done by external forces plus work done by pseudo forces. The pseudo force also have to include. Will be change in kinetic energy plus change in potential energy. So if you include these two, you are fine. So we have to include work done by pseudo force. Then answers come right. So if you ask me, this is a complete formula. This, even in non-inertial frame, it works. Have a look at this. In work per energy, right? But in loss of motion, what is the most important thing? Drawing a proper FPD. That is first most important thing. Second most important thing was getting the constraints right. And third step was writing equations and solving, force resolving. Similarly, in work per energy, right? The most important thing is defining your states. So can I turn the page? So how do you solve problems in work per energy? Steps to solve.
But can you go back for a minute? Yes, sir. Thank you.
Steps to solve. Step 1. Define your system. And to choose your system. And define your initial and final states. Because see, whenever you're conserving energy or something, what do you conserve? Initial and final. Na? So define properly, na, what is your initial, what is your final. I have seen most people, right? They don't define initial final properly. They get confused what the hell they're doing. So in work energy problems, the main thing is drawing the final diagram is the most important thing. How does it look in the final situation? Define the initial and the final state. Step 2, choose your reference line. Calculate gravitational potential energy, kinetic energy, and spring potential energy at initial and final state. Step 3, find work done by any external forces. If there are any external forces, find the work done. Stage 3, use work energy theorem and solve. Look at the steps. Let's see a problem on this. Do look at the steps. Clear? Can I go ahead? Let's see a question. Twenty meters. This is 10 meters. This whole path is smooth. And let this be some 5 meters. And this angle here is 60 degrees. So you took a block here, mass M, and release from rest. So this block slides here, goes like this, and flies and falls on the ground. So it hits the ground at an angle alpha. And this is your range. So let's call this point A and let's call this point B. The block slides from A to B and lands on the ground at point C. Find range and find alpha. Alpha is the angle made by the velocity vector on the ground. Let's get this. How do we do this? So let me help you with this one. Like I said, how to define your steps. Step 1, choose your initial and final state. In this case, it is pretty easy to see. This is state 1, this is state 2. Step 2, define your reference line. You can choose anything as reference line. You can take the ground as reference. It's important you follow the steps because later on when the problem becomes complex, this is what will save you, your systematic way of solving. Most of you have a habit of solving randomly. You just scribble and everything. When you go in the final advanced exam, J exam, doing your rough work properly is very important. What we have observed, right, with many students now, you guys, you have a paper, you start scribbling however you want. You write like this, you write like this, you write like this, write like this. And you get stuck with the problem and then you don't know how to follow the steps. And it happens multiple times. You keep coming back to check it again. And let's say, even if you don't write it properly, you don't get the question, you leave it and come back later, you don't understand where you have written, what you have written. Again, you have to start from scratch. So this was actually a kind of, a small study done in one institute where people tried it, Hyderabad. They found out almost people are losing, 20 to 23 minutes because of this returning, doing. 20 minutes is not a joke. So first thing, right, you need to learn how to do your rough work also properly. If you're solving, I'm not saying write beautifully, write it, but make sure all the steps are at one place so that you can refer back again when you come back. And these things, right, suddenly you won't learn all these things on the last day. You have to do this when you're learning now only. And try to keep it systematic. See, the more systematic when you solve, the faster you can be in the exam. So step 1, step 2, gravitational potential energy, mg 20. Spring potential energy, there's no spring, so I need not write, but I'm showing you. Kinetic energy, 0. Here the velocity is v. Gravitational potential energy, mg 10. I could have chosen this as only the reference line, but doesn't matter. Spring, there's no spring here. Kinetic half mv square. Are there any external forces on the system? Yes, there is an external force on the system. Normal reaction is there now. Normal reaction is an external force. There is an external force on the system, so be careful. Exam they'll ask you, is there an external force in the system? Work done is, if there is an external force in the system, work done is not 0. Not true. There is an external force, normal reaction. But what is the work done by normal? 0, right? Why? That's why we call it normal reaction. N is perpendicular to displacement. Whenever this guy is traveling, if you look at this, the normal reaction and the displacement are always perpendicular. The work done is always 0. So even though there's an external force, there is no work done. Therefore, work done by external forces is 0. Conservation of energy. Energy in state 1 is equal to energy in state 2. I know this is a pretty easy one, but see, the steps are important how you're framing it. mg 20, mg 10 plus half mv square. So this thing turns out to be, that is 200 minus 100, 100, 200. V is equal to 10 root 2 meters per second. Check. So once you got 10 root 2 meter per second, this whole question becomes like what? A projectile. I'll turn the page. So this whole question becomes like you have a building here of height 10 meters. And someone projected with the speed of 10 root 2 meters per second. What angle? What angle?
60.
30.
30 is
ये 60 था. So this will be 60. With the horizontal, the angle is 30. So be careful. It doesn't matter if you take the components properly. So this guy will be 10 root 2 cos 30. You can take 60 also. 10 root 2 cos 60 and sin 60. Same thing. 10 root 2 sin 30. So this thing comes and lands on the ground. Time of flight, how will you find that? Minus h. We are using h is equal to ut plus half at square minus h. 10 root 2 sin 30, that is 5 root 2 t minus half gt square. That would be 5 minus 2 root 2 t minus t square. That was a bad. This thing would be t is equal to root 2 plus root over 2 plus 8 by 2. Not a great answer. So what is range? Horizontal velocity into time. This is your time of flight. How much is this? 10 root 2 cos 30 is root 3 by 2 into time. I'll leave it there. You can simplify. And we have to find alpha. How do we do that? We can do something even more interesting here now. So this thing goes and lands somewhere here. This is your state 3. So you can even include energy in state 3 here. Here, the gravitational potential energy is 0. Spring is also 0. Kinetic energy will be half mvc square. So energy in state 1 is equal to energy in state 3. mg20 is equal to half mvc square. Mm cancels. We get vc is equal to 20 meters per second. And I hope you remember u cos theta is equal to v cos alpha projectile motion में. So u is 10 root t. This is cos 30. V is 20 and cos alpha. This is how you find alpha. This guy would be root 2 10 to root 2 by 2 cos 30 is root 3 by 2 is cos alpha. That's your angle, everyone. Please check the steps first. So first you need to find the speed at point B, find the speed at point C. That you get from energy. Once you get the speed, it becomes projectile motion question, and you get angle alpha by using that horizontal velocity remains same. U cos theta is equal to v cos alpha. Please check the steps. So once you found velocities, work per energy question got over here. After this is pure kinematics. In case someone thought kinematics got over, yeah, welcome back. Nothing leaves you. In physics, everything will keep harassing you till the last. It'll be like haunting you like a ghost. That's the best part about physics, and the bad part. Best part because it will be always you'll be in revised, with everything. Please check the steps. Look at the second steps. Clear? All clear with the steps. Next one. Next one. Turn in the page. Let's say we have block here A, B. This is 2 kg. This is also 2 kg. This angle is 30 degrees. This point is position P. This position is Q. So when the block comes here, this angle becomes 60 degrees. Anyone remember this question? We have done this in foundation.
Yes, sir.
And P to Q is 2 meters.
Yeah.
All surfaces are smooth. Find the speed of the blocks when block A slides from P to Q. This would be a good one, right? Find speed of blocks when A slides from P to Q. Let's get this. That point P, the angle is 30. When it comes to Q, the angle becomes 60.
So
Anyone
is
confused? There?
is initially at rest?
Yeah, initially rest. Initially system is at rest. I hope the question is clear, everyone. Try. The exam is online till tomorrow evening. Make sure to give it. The next test will be online Thursday night or Friday morning. Just give it a try, get some water and come. Yeah, 20 root 3 to 30 and root 40. Interesting. How did you guys get such an answer, right? Nah, all around. You won't get such a beautiful answer. It's pretty messed up, actually. When A goes from P to Q, how much will the block B travel? You guys forgot.
Meters.
How much?
2 meters, I think.
2 meters.
So, matlab, basically the length of the string.
God, you
length of the
remembered some
string
other
is-
answer. You just remember the answer for some question and you're just saying it. You
Oh,
don't
yeah,
even
I
realize
remembered
the
the method
you
also.
don't even realize what is the question. Why are you behaving like medical students? They do that only. They, they're like parrots. You give them one question, you change the question, they'll keep saying the same answer. It is not 2 meters, gods. First, find that one, everyone. How much will the block B come down when A goes from P to Q? Give me that. Let's solve the question later. First, get me that. How much will B travel when block A goes from P to Q? Get this, get this. That's a straightforward geometry question. That is not even physics.
Root 3 meters.
Nee, re, Aryan. How are you guys getting it wrong? Right? Get it? How much will block B come down when A goes from P to Q? But first find this thing.
2 times root 3 minus 1.
Ah, that is the answer. Now try. भूल गया. Everyone forgot that thing. See. Yeah, again. You guys are missing out a lot of steps, huh? This is a pretty good one, right? Problem looks pretty simple, but this is a proper advanced moderate level question. This. See, first thing, if you mark this points here, let's call this point some S. So if you take this triangle here, P, Q, S, this angle is 30 degrees. This is 60, na? So this is 120, this is 30, this is 120. If you drop a perpendicular, this guy will be 60 and this guy will be 60. This is 2 meter. This is also 2 meter. This will be 2 sine 60. Or you can use, sine rule also. 2 sine 60. So we get PS will be root 3 meters. And we have QS is equal to 1 meter. So distance traveled by block B, you're getting it this length minus this length. If you subtract these two lengths, the difference will be the distance moved by the block. Distance moved by B will be PS minus QS, which is root 3 minus 2 root 3 था ये. Two times. That's the distance moved by the block. This is the first part in the problem. All clear with this? This is simply the length of the string is constant. Then the second part of the question. Loss in potential energy is equal to gain in kinetic energy. There are no external forces here. Now the mistake what people do is this. Loss in potential energy, mgh. So we are talking about B only, mghb is equal to half ma ba square. Both the blocks will not have same speed. Half mb vb square. So if this is traveling with vb, this is traveling with va, and this angle is 60 degrees. You guys forgot constraints. This is tension, this is tension. T into va into cos 60 minus T into vb is equal to 0. We get va by 2 is equal to vb. A and B have different speeds. Both the blocks do not have same speed. Here, luckily, all have same masses, the m gets cancelled. So this will be 10. HB will be 2 into root 3 minus 1. This is half VA square will be 2 VB whole square. Plus this is half and VB square. That would be 4 plus 1, 5 VB square by 2 is equal to 20 into root 3 minus 1. 5s are 4s are 8s are. So VB is equal to 8 into root 3 minus 1 ka root. I hope I'm right. 5, 4, 2, 8 looks right. So VA will be VB by 2. That's your answer, everyone. Check the steps. So step 1, find how much will the block B go. Step 2, whatever energy B loses, because see, A ka height is always same. A is always on the ground here. So whatever energy B loses, that should be the kinetic energy of A and B. Step 3, A and B do not have same velocities. String constraints. And then once you got this, put it there and solve. Check the steps. This is a good one. You have constraints, you have work per energy. This is what I was saying. Physics now, this is how it goes. Literally, you can bring everything and combine them. And that's the best part. You will really love it. So don't get scared when things like this happen when you see multiple chapters. Be happy that you're getting revised. I'm sure most of you goofed up the constraints part. How many of you realize the speeds are different? Hands up. 1, 2, 3, 4 people. Okay. Check it out. Any steps you're not clear or not convinced, please ask me here.
Sir, tension is not work done by tension we don't take.
God, work done by tension is what? Is internal force, isn't it? Do you remember what is total work done by tension? Adrit, याद है constraints में क्या था वो statement? How did you get constraints?
Work done by tension, power of tension is 0.
0, right? So मतलब whatever work you're taking tension B ka, that is only going to A, na? So when you take A and B as one system, the whole work done by tension is 0. Tension is simply transferring energy from B to A. Tension is internal. So here my system is A and B together. Okay? Any steps? Anyone not convinced with any particular thing? Please ask. Let's see one more. Clear? Can I go ahead? Malika, clear, no? Anika, Ronak, clear? Neil, clear with this? Next one. This is fixed. We have a light rod here. Mass m. 2m. So it's a light rod with two particles. Think of like, with that barbecue में कैसा होता है ना पनीर का grill, like that rod with two paneer pieces. Able to visualize that way. This is a light rod. So this is length L. This is also length L. Released from horizontal position. So find the speed of the particles and the tension in the rod at the lowest position. When it becomes vertical. Let's get this. I hope the question is clear. We have a rod of length 12 and you kept two particles, one in the center and one on the edge, M and 12, and it is just rotating like. So when the rod becomes vertical, find the speed of the particles and find the tension in the rod. Let's see how many of you will fall in the trap. I dug a big hole there. I think I shouldn't have said that, no? No, there is no trap. It is a normal problem. Please do. So now you're confused, is it a trap or not trap? Solve. Try. 2 minutes, then I'll show you. Vartika, so far all clear? Arjun, clear
Yes.
stuff. Yeah. Vidyut, Niranjan, Aditya, all clear. Ronak, try. Okay. We got root 360. I don't know the answer actually, but I need to solve. But how did you get 360? But there is an L in the question, right? I got an answer without L. Huh. 360. I don't think so. You're right, but I don't get such a decent answer.
Sir, how to find constraints in rods?
How do you find? Think. That is the question. You're telling me, sir. Tell me where is the trap? Aditya. Yeah, Aditya got it. You have one answer, everyone. Find the tension also, Aditya. You have one answer. Try, others try. Take your time. Take a minute or two. No worries. It's fine if you don't get the answer. I don't care. But the point is, there are 5 steps. Figure out 1 or 2 steps. That's your job. Figuring out the steps. Understanding what is happening. You need to challenge yourself in the exam, not in the class. Class may you just need to absorb as much as you can. And my job is to teach you as many new things as possible. So keep absorbing. And make sure to try all these questions again once class gets over today. That is the most important thing. Root 60L. Listen, the first trap. I don't know whether you figured it or not. Will the speed of both of them be same? Yes or no? Speed is not same. That is the first catch. Think about it. When the rod becomes vertical, now someone was asking, Adrit, you're asking what is the condition for rods? For a rod, what remains same? Can the rod bend? No, right? So what remains same? Angular velocity, isn't it? When the
Yes,
rod is
sir.
rotating, the entire rod ka omega is same. So if you look at this point A here, this is traveling with V is equal to L omega. This point is traveling with 2L omega. Get the catch? Velocity is not same. So this is 2V and that is V. That is the first point. This is M and this is 2M. So omega of the rod will be same. Both the particles have same omega, not same velocity. Then loss in PE is gain in KE. So the first one, how much did it lose? The first one has fallen by this distance here, L. The second one has fallen a distance of 2L. So this would be mg L. This will be 2mg 2L. Energy will be half m v square plus half 2m. I will take it as 2v whole square. This would be 5 mgl and that would be 9 by 2 mv square. So v is equal to 10 gl by 9 ka root. That is the speed v. Check. Right, Adrit. That's the catch. Speed is not same. Most people, what they do, they take both is v and they try to solve, and that goes for a toss. So both of them are losing different potential energy. Both of them have different speeds. You have to take both as one system. You can't consider each particle. So whenever you have rods, what remains same is omega and velocity along the rod is same. These are the two concepts there. Rigid body constants. Clear? How do you find the tension? Now, see, this is how you should mind keep working. You ask me for tension. The moment you ask for tension, tell me till now which chapter taught you how to find forces? Laws of motion, isn't it? And what is the first thing you do in laws of motion? Draw an FBD. Game always starts like that. So if you draw your FBD here, so this is M. This is 2M. So this guy is fixed here. This is going with V and this is going with 2V. Now the point here is both the rods don't have same tension. Huh? This is T1 and this is T2. Tension is different in both the rods. If you take the lower particle here, tension T2, 2mg. Now don't forget you're going in a circle. Since you're going in a circle, there'll be centrifugal force or centripetal acceleration, whichever you want to use, you can use. If you use centripetal acceleration, observer is on the ground. If I use centrifugal force, my observer is standing on this. I hope that point everyone is clear. So from here we get T2 is equal to 2mg plus 4mv square by L. V square is how much? V is root 10 gl by 9. So substitute this here 10 gl by 9. That is 40 by 9. 18. 40 plus 18 is 68 mg by 9. Am I right? Looks right. Looks right. And what about this guy here? T1,
It is
your own
58,
weight mg. Are
58 mg.
40 plus this thing, no? Yeah, 58, you're right. And the tension T2, and you also have a centrifugal force. There are actually three forces. T2 and mv square by L. So T1 will be mg plus T2 plus mv square by L. So that is mg, and T2 is 58 by 9, and mv square by L is again 10 mg by 9. 68 plus 9, 77 mg by 9. The numbers are not that great. Please check. So the entire rod has two different tensions. Upper rod and the lower part, the tensions are different. Check your steps. It's a good one. You can calculate this. You want to use centripetal acceleration, you can do that also. You want centrifugal, you can do that also. Generally, we'll use centrifugal force one, but nothing wrong. Clear with this? Any steps not clear, please ask. Next one. Let's see one more. Let's do an easy one. We have a bowl like this. This is rough. Nu is 0.1. And this whole length is 10 meters. A standard question. So on this side, it is smooth. This side is also smooth. Mass M. So it released from rest, and this height here is let's say, let's make this thing 0.2. Let's make this thing 7 meters. Make it 7.5 meters, better. So the question is, block is released from rest. Find the point where the block stops. So basically what will happen, this block will slide. So when it enters the rough surface, it will slow down, slow down, slow down, slow down, then it again goes up, but it won't go to the same height. Again, it will come back, slow down, slow down, slow down, doesn't go to the same height, slow down, slow down, slow down, finally stop. Where will the block stop? Find the position where the block stops. Let's get this. Any answers? Right. About a minute more. Oh, by 15. See now, first thing, what is work done by friction? Work done by friction will be minus mu mg into s. Because when the block is traveling, the friction and the displacement, velocity of the block, no, block is stopping. Eventually, the block will stop. Work done by friction is minus mu mg into s. S is what? S is the distance traveled by the block on the rough surface. This is not the total distance. Think about it. Friction will come only whenever you're traveling on the rough surface. So mu mg s is the distance traveled on the rough surface. Are you getting it? Now, using work energy theorem, look at this scenario here. State 2, the block eventually stops here, V0. State 1, the block is here. Potential energy, mg, h. Kinetic energy, 0. State 2, potential energy, 0. Kinetic energy, 0. You lost all the energy. So who is eating away all the energy? Friction. You can directly say that and finish it off. So that means all the potential energy is eaten by friction. But okay, let's do it in more formal way. Work done by external force is change in potential energy plus change in kinetic energy. So work done by external force is minus mu mg into s. Change in potential energy, final potential energy 0, initial potential energy minus mgh. Kinetic energy, finally 0, initially also 0. We end up with s is equal to h by mu. This is the distance traveled by the block on the rough surface. Here h is given as 7.5 and mu is given as 0.2. So this guy would be 37.5 meters. Means what? It has traveled a total of 37.5 meters on the rough surface. So when you're traveling from A to B, this is what you're doing, everyone. First you went 10 meters. Then you came back 10 meters. Then again you went 10 meters. And this time you traveled 7.5 and stopped. Isn't that what it means? You're just traveling to and fro every time. You travel 10 front, 10 back, 10 front, and then you came to 7.5 and you stopped. So first you travel 10 meters. Then you went onto the smooth surface. Energy is not lost. You came back again 10 meters. Again you came back 10 meters. And then you traveled 7.5 and you stopped. Meaning this blocker distance, right, is it 7.5 meters from A, from B, or 2.5 meters from A. Are you getting how we did this? I found the total distance traveled on the rough surface. That is 37.5. So you lose energy only when you are traveling on the horizontal rough surface. I don't care what happens on the smooth surfaces. Because with whatever speed you go up, you'll come back with the same speed. So you don't lose any energy on the smooth surfaces. Check it out. Any doubts on this? It's a good one. This would be a typical mains level question. So options will be like that only. 2.5 meters from A, 7.5 meters from B, and so on. That's the most general form actually. S is h by mu. So h is the height and mu is the same. Clear? All got this? Any doubts on this? Abhinav. Abhinav, any doubts?
No, sir.
Clear? Let's see some homework problems. Definitely try this at home and come, because these are good. This will take time. You need to spend some time thinking about it. So first thing in the class, we'll be discussing them in the next class. We have a block M. We have a spring. Initially, the block is at rest. The spring is in natural length. This is K. And this is point A here. So someone started pulling this point with speed U. A is pulled with, this will be a good advanced paragraph question. Huh? A is pulled with constant speed U. So the first question, find maximum elongation of the spring. Second question, find maximum speed of the block during the entire process. Find work done by external force. Now see, if it is pulled with constant speed U, someone is pulling, right? It won't go on its own. That means there is some external force. I don't know how much is that. It's not given. Find work done by external force till the spring reaches maximum elongation. When spring is max elongated. D part. If A is pulled with constant acceleration, instead of constant speed, if you're pulling with constant acceleration, if A is pulled with constant acceleration A, find max elongation. There, these are 4 questions, right? So pretty good one. Is the question clear? So we have a spring there. Someone caught that one end of the spring and started pulling with constant speed. So initially what will happen? The block will be here. Spring thoda aage jayega na, because it will stretch. Because the spring got stretched, what will happen? The block will start moving now. And then the motion will be like this, isn't it? Spring is stretching, block is going. Spring is stretching, block is going. So it is like a caterpillar ka motion. It is going front and back. So the point is continuously going forward, but this block is simply oscillating like this. And if you look at the motion, this is how it looks. See. This is point A. So after some time, this will come here. Point A will go here. Then try to understand, okay? Let's say this speed is 0. This speed is U. This is U. This is V. Here U is still greater than V. And the spring is pulling it, no? The block is actually accelerating. After some time, the spring will stretch more. A will come here. This is going with U. This is going with V. U is still greater than V. At some point, you went so fast, both the speeds become equal. But remember, spring is still pulling. So matlab block ka speed abhi bhi increase hoga. But now this time spring will start compressing. Block will come here. This is getting closer. This is U. This is V. V becomes greater than U. Are you getting how the motion goes? As the A is going forward, this block at the picture is oscillating front and back. Is the scenario clear, everyone? Everyone? Vartika, Arjun, Abhinav, is the scenario clear what is happening with the system? Huh, Abhinav?
This was basically going ahead, right?
Point A to aage ja raha hai, but this guy is oscillating front and back and A is dragging it front.
Okay.
Okay? Think of like this. I'll tell you a better analogy. Aisa socho na. Let's say you have a truck here. We have a spring and a block. Now, if you're standing on the truck, आपको spring कैसे दिखेगा? Front back, right?
Yes,
The
sir.
spring will simply go front and back, no?
Yeah.
Truck itself is going forward. Are you getting it?
Huh.
are able to visualize the motion now? The spring block is simply oscillating and the truck itself is going forward.
Ah, okay,
You-
understood.
I hope that motion, that part was clear. It is like you are in a bus or something. You have a block here and you have a spring. So this block is oscillating inside the truck like this. And this whole truck itself is going forward. Now it makes sense. That is how the motion looks. Someone is just dragging this point forward with you. Clear? That's the question. So do try this and come next class when we will discuss this thing first thing in the class. It's a good one. Spend some time, 15-20 minutes, that is worth it. So okay, with this we'll wrap it up. So I think you can, if you start doing work per energy, you can start doing HCV or your booklet, whatever you're doing, you can do the starting. You'll be able to handle most of the questions except work per this thing, power and vertical circular motion. On Friday, when we catch up, we'll continue more. We'll do more deadly problems on Friday. We have started, like, the main thing has started. The starters got over, now the main course. Okay, so we'll wrap up with this. So do make sure to get the exam by tomorrow. So any doubts, anything, please stay back or else you're free to leave. I'll see you on Friday at the same time. So take care, stay safe.
Bye, sir. Thank you, sir.
Bye, Ray. Take care.
Bye, sir. Thank you, sir.